Hi everyone. In today's video, I will be going over this Unit 2 practice test. What this is it's a way to just review the ideas that we covered specifically in Unit 2-2. Because we don't give an actual test over it, the material just appears on the benchmark. So we like to give you this practice test just to really hone in on those skills. Number 1. Write a polynomial function given its zeros, and our zeros are -3, 4, and -5. This actually comes from Unit 2-1, so I just wanted to mark it as such in case anyone goes through their 2-2 notes and they can't find notes on this type of problem. It's actually an old problem. So these are zeros. First, we need to write these as factors. So if we were to write these out as just x equals, we'd have x equals -3, x equals 4, x equals -5. And then we would want these equal to 0. So we'll bring all of the numbers over to the left side with x, giving us x plus 3 equals 0, x minus 4 equals 0, and x plus 5 equals 0. So the portion on the left side, these are referred to as the factors. We put those in parentheses. So we have x plus 3, x minus 4, and x plus 5. A lot of students are at the point where this change from the zeros to the factors is automatic. So this was just a short explanation showing how and why we get there. From here, we just need to multiply all of these together until we get one long polynomial function. So we need to pick 2 of these to multiply first. For format purposes, I like to multiply the back 2, so then when I multiply the x plus 3 and later, it's coming from the front. So we're just going to FOIL. I'm going to bring down the x plus 3 ahead of time. X times x is x squared. X times 5, that's 5x. -4 times x, that's -4x. -4 times 5, that's -20. As always, I have like terms to combine in the middle here. So that's going to give me x squared. This is just plus x minus 20. And then I'm going to distribute the x plus 3 into here. I'm going to distribute the x through first. X times x squared, that's x cubed. X times x, that's x squared. X times -20, that's -20x. And now for the 3. 3 times x squared, that's 3x squared. 3 times x, that's 3x. 3 times -20, that's -60. And then from here, I'm going to make my final polynomial. As I go, I'm going to make sure I put the terms in order, and I combine like terms as I can. And I like to mark off the terms as I go since there's so many. That way I don't forget any of them. So the first term is going to be that x cubed. It is the highest. Next, my x squared. So I've got x squared and 3x squared. When I combine those, I have 4x squared. And then I have my minus 20x and plus 3x. That's minus 17x. And then lastly, the minus 60 at the bottom. And there's the polynomial with these zeros. Reminder, you can always plug this into your calculator and graph it and make sure that it crosses the x-axis at these 3 numbers. Just a quick way to check and make sure you did your math right. Number 2, use direct substitution, otherwise known as the remainder theorem, to find f of -5 given f of x equals x cubed minus 5x plus 2. The remainder theorem basically says when you plug a 0 into the function, the number that comes out of it is the remainder you would get if you were to do synthetic division. So remainder theorem is much quicker than synthetic division. So f of -5 is exactly what you think. Plug -5 in for x. So we have -5 cubed minus 5 times -5 plus 2. You're welcome to just put this into your calculator if you like, but I prefer to do things by hand. -5 cubed is -125. -5 times itself is positive 25 plus 2. -125 plus 25, that's -100. plus 2 gives us negative 98. If you didn't do that with a calculator, you are welcome to check it. Make sure you get the same number. Number 3, simplify. Square root of negative 45 plus the square root of negative 80. First off, we need to rewrite both of these without that negative under the root. So we're going to have I square root of 45 plus I square root of 80. Next, we need to simplify these radicals. So let's start with the 45. You're welcome to go about this any way you want. The most common factors of 45 are 9 and 5. 5 doesn't break down, so I'm going to underline it because I know it's part of my answer. 9 breaks down into 3 and 3, which makes a pair. So that means 3 is going to come out and join the I. So we have 3i square root 5 plus, we're going to do the same thing with the 80. 80, the two factors that come to mind for me are 8 and 10. I'll break down the 10 because that one's really easy. It's just 2 and 5. I can't do anything else. So these are going to be my answer. I'm going to mark out that 10 because I broke it down, so I'm going to not look at it. And then 8 breaks down into 2 and 4. Kind of got ahead of myself there. And then 4 breaks down into 2 and 2. Sorry if this is a bit messy. Let me get a different colored marker when I do this just to help organize it a little bit. So I broke down the 8 and the 4. I'm going to mark those out so I don't focus on those. So I have a pair of 2's here. And I also have another pair of 2's here. And then I have the square root of 5. So both pairs of 2's come out. So this is 2 times 2, which gives us 4i square root 5. And then lastly, these are like terms now that they both have I square root 5 on them. So I can just add that. And I end up with 7i square root 5. And that is my answer. Number 4, write the following expression as a complex number in standard form. 9 minus the square root of negative 49i. Standard form, just a reminder, is a plus bi. So you write the real number first and then the imaginary number second. So we can rewrite this negative 49. First off, we have 9 minus, this should be I square root of 49. And hopefully you recognize the square root of 49 as a perfect square, which is 7. So this becomes 9 minus 7i. And that's all we can do. This is our answer. Number 5, we have 5 minus 2i times 3 plus 2i. This is multiplication, so we're going to FOIL. 5 times 3 is 15. 5 times 2i, that's 10i. Negative 2i times 3, that's negative 6i. Negative 2i times positive 2i, this is negative 4i squared. 15, in the middle we have like terms we could combine. 10 minus 6 is 4i. Minus 4, I squared is negative 1. So this is negative 4 times negative 1. So we have 15 plus 4i plus 4. Lastly, we're going to combine 15 and 4 to get 19 plus 4i. This is our answer. Number 6. 27 minus 15i minus 10 plus 17i. First off, this is not multiplication, this is subtraction. However, a trick to handle the subtraction is we treat this like a negative 1 that needs to be distributed. So I'm going to rewrite the first part. 27 minus 15i. And then my new number I'm going to write here. Negative 1 times 10 is negative 10. This is still minus 10. We're not multiplying the terms themselves here. Negative 1 times 17i, this is negative 17i. And now we can easily combine like terms. 27 minus 10 is 17. Negative 15i minus 17i, this is negative 32i. Number 7. 1 over 1 minus 7i. To get rid of the I on the bottom of the fraction, because reminder, you're not allowed to have I on the bottom of a fraction, we have to multiply by the conjugate here. So the conjugate is done by just changing the sign that's in front of the I only. Don't change the sign in front of the other number, in front of the real number 1. So we're going to multiply by 1 plus 7i on the top and the bottom. And from here, we're just FOILing on top and bottom, really just on bottom to get our answer. So 1 times the top, that's not going to change anything. Over the bottom, 1 times 1 is 1. 1 times 7i is 7i. Negative 7i times 1 is negative 7i. Negative 7i times positive 7i is negative 49i squared. Don't forget to do that multiplying of the 7s and the i's there. Now these conjugates are actually difference of squares, so when you do this FOILing, the middle 2 terms should always cancel out. So now we have 1 plus 7i over 1 minus 49, and we discussed earlier that I squared is negative 1. So we'll change that to negative 1. 1 plus 7i over 1 plus 49, almost done. 1 plus 7i over this is actually 50. Now reminder, we need this to be in standard form, which is a plus bi. So right now this is a combined fraction and we need to separate it. So let's separate this into 2 fractions. We have 1 over 50 plus 7 over 50i. You're welcome to put the I up on top with the 7 if you like, but I like to put it next to the fraction. This is now split up into 2 separate numbers, the real part and the imaginary part. This is our answer. Next page. Find the roots of the following equation. X squared plus 6x plus 13 equals 0. So this is a quadratic. We have x squared. First thing you check for is if you can factor this. Thinking aloud here, we'd be working with the factors of 13. 13 only has 1 in itself, and there's no way to get 6 from that, so I'm not even going to waste my time. Since we can't factor it, we have to use quadratic formula, which is not on the front of this here. I'm going to write down the quadratic formula for us to reference. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So we have ABC. A is 1, B is 6, C is 13. So we have x equals negative 6 plus or minus square root 6 squared minus 4 times 1 times 13 all over 2 times 1. Negative 6 plus or minus square root 36 minus 52 all over 2. Negative 6 plus or minus square root. I feel like that's negative 16, but I'm second guessing myself. It is. Okay. Negative 16 over 2. Negative 6 plus or minus. We have I square root 16 over 2. Negative 6 plus or minus. Square root of 16 is 4, so this is 4i over 2. Now remember, this needs to be in a plus bi form, so we need to separate these two. We have negative 6 over 2 plus or minus 4 over 2i. Lastly, we have negative 3 plus or minus 2i. These are the roots of the equation. Number 9. What are the roots of the equation below? You're welcome to do quadratic formula if you like, but that would actually be overkill on this problem. This is a very basic factoring problem. So let's factor. We have our ACB chart. A is 1, so we just look at C, which is 2, and B is negative 3. 2 only has one pair of factors, 1 in itself. To make negative 3, we have to have negative 1 and negative 2. That does give us negative 3. And then when I multiply them, I still get a positive 2, so that works. So my roots are x minus 1, x minus 2 equals 0. Once you factor, we now separate these, and we individually set them equal to 0. X minus 1 equals 0, x minus 2 equals 0. So that gives us x equals 1 and x equals 2. For the next two, we need to do two things. We're going to A, list all possible zeros, and B, find all zeros, both real and imaginary. So when it says list all possible zeros, it's asking for the P's and Q's. These are all the possible zeros of the equation, but they're not all going to be zeros. So A, P's and Q's. So these are factors of the constant over factors of the LC, the leading coefficient. So our constant is 10 and our leading coefficient is 3. So on the top we have plus or minus factors of 10. So that's plus or minus 1. It's 1 and 10 go together. And then we've got plus or minus 2 and plus or minus 5. Over. The factors of 3 are just 1 and 3, so plus or minus 1, plus or minus 3. Now we have to make our list of possible zeros. So we treat this as a giant fraction, and these are our possible denominators. So I'm going to go through once and use all of the numerator options with 1 as the denominator, and then I'll go back through it again with 3 as my denominator. So over 1, they're just whole numbers, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. And now I'm going to go back through with 3 as the denominator, plus or minus 1/3, plus or minus 2/3, plus or minus 5/3, and plus or minus 10/3. This is my list of possible zeros. So if the zeros appear on the graph, they are going to be in this list. B, find all zeros, both real and imaginary. So we're actually going to use our calculator to help us out with this part. Let me adjust the brightness here. All right, this should be good. So I'm going to graph this equation. I'm going to adjust the brightness a little bit more. Okay, that is much better. All right, first off, if you're watching this video and you do not have your calculator in this mode or have never been shown how to do this, let me show you real quick. It's really helpful for this problem. So I'm going to go to mode. About halfway down the screen, you'll see these options: full, horizontal, and graph table. If yours is in default mode, it's going to be in full, which is where the graph takes up the screen. I like mine in graph table, so you just arrow over to it and hit enter. It's going to regraph it. Let me see if I can turn this down. Nope, that's it. Okay, that'll have to do. So what I like about this mode is when I go to table, second table, as I move down the table, points will appear on the graph as I move through them. So it's a very helpful tool. So let's go back. I clearly have a 0 at 5. I have one at 2. And then this one here, you can't see. As you can see, it just jumps right over it. So we know that we have x equals 2 and x equals 5. And clearly we have a third one here. Reminder, check your degree when you start the problem. This is a degree of 3, so we're looking for 3 zeros. So keep that in mind. So clearly we have a third 0, but we can't tell what it is. So we're going to have to figure it out. So right now it's just a question mark. So the calculator gave us something to start with. Let's go from there. So what we need to do is we need to do synthetic division with the original equation. And we're going to divide 1 by 1 the polynomial by the 2 zeros that we have. And then the polynomial that's left after that, we're going to solve that. We'll set it equal to 0 and solve to get the last x value. So, as I said, I'm going to divide by both zeros. I'm going to start with 2. You can do these in either order. My coefficients are 3, negative 20, 23, and 10. We're not missing any place values here, so I can just copy these down. Synthetic division. Bring down the first number, which is 3. 3 times 2 is 6. Negative 20 plus 6 is negative 14. Repeat. Negative 14 times 2 is negative 28. 23 plus negative 28 is negative 5. Last time, negative 5 times 2 is negative 10. When I add those together, I get 0. Remember, you must get a 0 here. If you don't, a mistake has been made. So I have divided by the first of my zeros. So I can't do it again. Now I'm going to divide by x equals 5, my next 0. Now you could rewrite this, set up a new synthetic division, but it's convenient to just continue on the pattern with the numbers already set up. So I'm just going to continue right where I left off. This is now being divided by 5. And when I draw this line, I'm going to stop before I get to this 0. Remember, this 0 is the remainder, so it's no longer part of the polynomial numbers. So I'm only going to use the first 3. And then I continue. Bring down the first number, which is 3. Ignore the times 2's up here. 3 times 5 is 15. Negative 14 plus 15 is positive 1. And then 1 times 5 is positive 5. When I add these together, I get 0 again, which I'm supposed to. Now I'm going to make the new polynomial here. So, reminder, this is a place value thing. So this is the remainder. So the next place value from there is the constant, which I just like to write no x, just as a reminder. It's just this number by itself. And then the next number gets an x. And then if I went up from there, if I had more numbers, it would go x squared, x cubed, x to the 4th, so on and so forth. So I need to write out the polynomial that's left over. It's called the depressed polynomial. I just like to call it the DP for short. So we have 3x plus 1, no x on it. This is what's left after breaking down the polynomial. So I need to figure out the last 0. So set it equal to 0 and solve for x. Subtract 1 on both sides. We get 3x equals negative 1. Divide by 3. X is negative 1/3. So that is the missing 0. So I'm going to make my final list now. So we have x equals 2, x equals 5, and x equals negative 1/3. These are the 3 zeros of the graph. I never checked off that 5 earlier after I divided by it. And there you have it. which, by the way, all three of these are in the possible zeros list. Let's do that again. F of x equals x to the fourth minus x cubed minus 4x squared minus 2x minus 12. First, the p's and q's, all the possible zeros. So our constant is 12, ignore the negative, and then our LC is actually just 1, and we are looking for 4 zeros this time. All right, so on top we do plus or minus the constant factors. So it's plus or minus 1 and plus or minus 12. Next we have plus or minus 2 with plus or minus 6. And in the middle we have plus or minus 3, plus or minus 4. Luckily for us, 1 is really easy. That's just going to be itself. So all of our possible zeros are actually just the top numbers here. So I'm just going to repeat that list. Since it's all over 1, it's just the whole numbers. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. All right, B. Let's find actual zeros. This is where we use the calculator to help us out. So again, type in that polynomial. All right, I don't know how well you can see the calculator from this, but let's take a look at these zeros. So we can only see 2 of them. We can see x equals negative 2 and x equals 3. I just forced the calculator or the camera to focus a bit more, so hopefully this looks better. So yeah, so we have 2 zeros, one at negative 2 and one at 3. Now reminder, we're supposed to have 4. So I have 2 unknowns. There's 2 possibilities here. 1, both zeros are outside of this window, so we can't see them. Or 2, we can't see them because they're not there, meaning they're imaginary. So we can still find them, you just won't be able to get them from a graph. So let's do the work. Synthetic division, I'll be able to do it twice. So first I divide by negative 2, the first zero. Set up the coefficients. We have 1, negative 1, negative 4, negative 2, and negative 12. First we bring down that 1. 1 times negative 2 is negative 2. Negative 1 and negative 2 is negative 3. Times negative 2 is positive 6. Negative 4 plus 6 is positive 2. Times negative 2 is negative 4. Negative 2 plus negative 4 is negative 6. And lastly, negative 6 times negative 2 is positive 12. And when we add that, we get 0 like we're supposed to. So we just divided by the first 0. Let's do that again with the next 0, which is 3. And I didn't mean to go that far, but I'm not going to take it out to the 0. Let me mark that off real quick. There we go. All right, bring down the 1. 1 times 3 is 3. Negative 3 plus 3 is 0. 0 times 3, well, that's still going to be 0. 2 plus 0 is 2. 2 times 3 is 6. Negative 6 plus 6, 0, like it's supposed to be. We are out of zeros to divide by, so now we have to turn this back into a polynomial and see what we can do. Place value, this is remainder, the constant, so it has no x, the x term, and the x squared term. So the dp, the depressed polynomial, is 1x squared plus, I'm going to write it, but I'm going to drop it in a minute, 0x plus 2. So let me rewrite that as just x squared plus 2. And then to find the missing zeros, we're going to set this equal to 0 and solve for x. This will not factor. This is not a difference of squares, so don't fall for that. Since we only have one x term, we can just solve for x, which is what I'm going to do. But if you prefer quadratic formula over that, you can still consider doing that as well. All right, so I'm going to subtract 2 on both sides. We have x squared equals negative 2. Next, I square root both sides. This gives us x equals, don't forget that plus or minus the square root of negative 2. Which is x equals plus or minus 2i. And that's wrong, hang on. Let me pause this real quick. All right, let's try that again. I square root of 2. Sorry, I don't know why I took the 2 out. The square root of 2 is not nice. Keep it there. Bring the I out. That's better. And then, so those are the two missing zeros. We've got the positive and the negative case, so this is 2 zeros. And then I'm going to bring down the other 2 zeros as well, which were negative 2 and 3. And this is my answer. Next, number 12. Number 12, we do something very similar, but we don't want you to use the calculator. So here's what it says. Given 1 0 of each polynomial function below, find the other zeros, and then I added in bold, algebraically without a calculator. Number 12, you can cheat. This, you can see all of them on the graph, so please do this by hand like we ask you to. 13, on the other hand, if you try and graph this, you're going to get nowhere, so we have to give you this. So basically, we're handing you one of the zeros to start with, and then you have to solve it from there. So, to find the other 2 zeros, because we have 3 that we're looking for, we know one of them, it's 2. So let's divide the polynomial by 2. Our coefficients are 1, negative 2, negative 9, and positive 18. Synthetic division. Bring down this one. 1 times 2 is 2. Negative 2 plus 2 is 0. 0 times 2 is still 0. Negative 9 plus 0 is negative 9. Negative 9 times 2 is negative 18. And we get 0 like we're supposed to. That's the only 0 that we have to divide, so we need to turn this into the depressed polynomial and go from there. So remember, this is remainder constant, so no x, x, x squared. So we get 1x squared plus 0x minus 9. I'm going to write that again. X squared minus 9 if we drop all the nonsense things. Set that equal to 0 and solve. You have a couple options here. You can either just solve for x like I did in the previous problem. You can use quadratic formula, or hopefully you recognize this is a difference of squares. We can square root the front and the back terms, and we've got subtraction, so we can do that. That's what I'm going to do. This gives us x plus 3, x minus 3 equals 0. Set both of these equal to 0 and solve. Solving, we get x equals -3 and x equals +3. Now the question was find the other zeros. So technically these are the answers, just these two, not including the 0 that we started with. Let's do that again. 13. So we're given a 0 to start with. It's -3/2. You are welcome to turn this into -1.5 if you like, but I do challenge you to work with the fraction. This problem is not hard at all with the fraction. Coefficients, we have 2, 3, 18, 27. Bring down the 2. 2 times -3/2. That's -6/2, so that's actually just -3. Adding, we end up with 0. 0 times -3/2, well, that's still 0. 18 plus 0 is 18. 18 times -3/2. If I do that, 18 times 3, can't think of that off the top of my head. That's 54, and then half of 54 is 27. So this is -27. When I add this together, I will get 0 like I'm supposed to. And again, that's the only 0 we are given to factor with. So from here, we just have to turn this into the depressed polynomial and solve it by hand. So again, we have remainder, no x, x, x squared. Just using the raw numbers, we have 2x squared plus 0x plus 18. And then I'm going to drop that middle x term, 2x squared plus 18. Set it equal to 0 and solve. So you are welcome to just straight up solve for x if you like. You can use a quadratic formula, or I challenge you to factor it. Choice is yours. So you can factor this slightly. There is a GCF of 2 here that I'm going to pull out. That leaves us with x squared plus 9 equals 0. And then when we split and solve, basically we're just going to get rid of this 2, if you will. So actually, I'm just going to divide off the 2 on both sides to make this easier for myself. The 2 goes away completely, as you can see. So we're just left with x squared plus 9 equals 0. And then we just solve for x. Minus 9, we get x squared equals -9. Square root both sides. Don't forget that plus or minus. We have x equals plus or minus the square root of -9. X equals plus or minus. I comes out, but 9 is a perfect square, which is 3. So this is plus or minus 3i. These are the missing zeros. There are 2 of them here. And that's it. Number 14. Sketch the graph of the polynomial function below using its roots. Describe the end behavior. So we have f of x equals x cubed minus 8x squared minus x plus 8. P's and Q's, we've been doing this. So our constant is 8. And our leading coefficient is 1. So this is plus or minus the factors of 8 over plus or minus 1. So factors of 8 are 1, 2, 4, and 8. All over plus or minus 1. So really, it's just the top list on the fraction. Plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8 all over 1. Roots. We have our calculator. Let's use that to our advantage. And let's see which zeros we can identify. So we have second table. -1 is a 0. One and 8. And there are 3 zeros total, so we have all 3 of them. All right, let's plot those points. We have -1, +1, and 8. Y-intercept, I'll do that one by hand, that's really easy. Remember, if we're looking for the y-intercept, that means x is 0. So just plug 0 in for all the x's. We have 0 cubed minus 8 times 0 squared minus 0 plus 8. So that gives us 0, 0, 0 plus 8. So 8. Our y-intercept is 0, 8. And we can sketch our graph from here. Again, we can kind of use the calculator to guide the way our lines are going to go. So on the left side, clearly this line is going up from below, so the arrow is going to go this way. So we start here, we go up, then we go back down, and then we go down for a bit. Eventually it's going to turn back around, and then it's going to come back up here to hit the 8. And then it's going to keep going on up forever. So for the end behavior, don't overcomplicate this. As x goes to -infinity, so that means when we're looking at the left side of the x-axis, where's the graph going? So the left side of the graph is right here. If we're talking about the graph itself, it's going down. So it's going down to -infinity. And then if this is the left side, positive infinity is the right side. So as we look at the right side of the graph, where is it going? That's what it's saying. The right side of the graph is going up. So it's going to positive infinity. Back side, last problem. Graph the rational function and fill in the information below. We have f of x equals x squared plus 5x plus 4 over x squared minus 1. And some of this information will be given to you on the benchmark. Let me show you specifically what. So on this sheet that we gave you to help you with these steps, we're going to give you this here. So basically what you can see on the screen right now, that information will be given to you. We'll tell you to factor, we'll tell you about the holes, we'll tell you how to find vertical asymptote, and then we'll tell you how to find horizontal asymptote. So I will be using this as I go. So step 1 is factor. We have x squared plus 5x plus 4 over x squared minus 1. We need to factor that. On the top, we just need an ACB chart. A is 1, C is 4, and B is 5. Now we're looking for factors of 4 that will give us 5. Factors of 4 are 2 and 2. That's not going to work. 1 and 4 will work. And actually, when they're both positive, we will get a 5. And when multiplied, we still get 4. So this is x plus 1, x plus 4. On the bottom, x squared minus 1. I hope you recognize that. That's a difference of squares. X plus 1, x minus 1. So these are going to cancel, the x plus 1s. And so what's left over is x plus 4 over x minus 1. So that was the first step. Holes. The holes are the factors, when factored, the ones that cancel it out specifically. So the hole is for x plus 1. I'm going to come down here to do this work. So what you do is you take the canceled out factor and you set it equal to 0. So we have x plus 1 equals 0. So that means x equals -1. Now we need a point for this whole. So we have half of it. We know it's -1. We need to find the y value. To find the y value, you plug this into the factored form, not the original. If you plug it into the original, you're going to get an error. That's why it's a whole. So you need to plug it into the factored one. So we have y equals, I'm going to just write the original, x plus 4 over x minus 1. And then I'm going to plug in the x value. So we have -1 plus 4 over -1 minus 1. -1 plus 4, that's +3. -1 minus 1, that's -2. So that's just -1.5. So this is the location of the hole. Next, the vertical asymptote. The vertical asymptote, you take the factored form because you want to look at it after the holes have been removed, and you're going to set just the denominator equal to 0. So we're going to take x minus 1 and set it equal to 0. That's going to give us x equals 1. This is the equation of the vertical asymptote. Domain, I'm going to get back to that. Horizontal asymptote. So you want to look at the factored form. So we have x plus 4 over x minus 1. So when we do this, there's a rule that we're following. We want to only look at the highest term on the top and the bottom. Anything else we want to ignore. So I want to focus just on the x's here. Those are the biggest terms. So we have x over x. And we care about two things. Well, we care more about one over the other. It just depends. The first thing we care about are the exponents. These both have an exponent of 1. So on the top, this is called n. This is the exponent is referred to as n, and on the bottom is referred to as m. That's just following the notation in this box here. So in this case, n and m are both 1, so n equals m. So now the second thing we care about, because this is the scenario we have, when n equals m, then this is the equation of your horizontal asymptote, y equals a over b. Let's go back up here. A and B are the leading coefficients of those terms on the top and the bottom. So, because we have n equals m, we have y equals a over b, which is just the leading coefficient over the leading coefficient. So going back over here, the leading coefficients are both 1, because that's what's in front of those x's. So it's just 1 over 1, which is 1. Our horizontal asymptote is y equals 1. Range I'll come back to. X and y intercepts. X-intercepts is where y is 0. Now let's go back to this paper here real quick. Unfortunately, this hint I'm about to give you, it will not be given to you on the benchmark, so just keep that in mind. The x-intercept trick is to set the numerator equal to 0 and solve. So let's go back to the factored form. So we're just saying do x plus 4 equals 0. The reason we say that is because the bottom, when you do the algebra, this cancels out every time. So you can ignore this and just focus on the x plus 4. But I can show that if you'd like me to. So if we have x plus 4 over x minus 1 equals 0, so y is 0 here, and we try to get rid of the x minus 1, we do that by multiplying the denominator off of the bottom. because we don't like fractions here. This is to get rid of the fraction. Now clearly this is going to cancel over here, but also this just becomes 0. So it's really just the top equals 0. So if you know the trick, it just saves you a little bit of time. And then solving, we get x equals -4. So the x-intercept is -4, 0. Y-intercept, this time x is 0. Reminder, we're plugging this into the factored equation, not the original. So we have y equals 0 plus 4 over 0 minus 1, which is 4 over -1, which is -4. So our point is 0, -4. Going to fill these in above. X-intercept, -4, 0. Y-intercept, 0, -4. All right, now let's fill in some of the points that we have. We have a hole at -1, -1.5. It's going to be about right here. Now this is a hole, so you're not drawing a point, you're drawing an open dot. Next, the vertical asymptote. This is a vertical dashed line through 1 on the x-axis. So right here. Horizontal asymptote. This is a horizontal line through 1 on the y-axis. And then our intercepts, -4 on the x-axis and -4 on the y-axis. So without the calculator, you can already kind of see the shape of this forming. Let's look at the calculator to get the rest of the graph. When you graph this, you need to graph the original equation. The new equation here is to help us find things by hand without the help of a calculator. But at the end of the day, this is a different kind of graph from the original. So when you actually make the graph, it's of the original problem, not of the factored form. So I'm going to go ahead and sketch the curve on the left side here because you can clearly see it already. Now in the directions it says plot at least 3 points. For me, this hole here does not count as a point because technically it's not real. And also, I have a whole part of the graph I'm missing, so I'm going to need at least one more point anyway. So let me go through the table and find a nice point. 2, 6 looks pretty good. You can get more points if you like. The rest of them are fractions. Oh, wait, no, they're not. Sorry, 6, 2 is also good. I'm going to go ahead and graph that one. All right, now I can make a nice curve. And there you have it. Just a side note, you can very easily check some of the information we've already found. So, like the hole, for instance, when you go to -1 on the x-axis, there's an error. That's because of the hole. And it won't show you where it's supposed to be at. Like we were able to get the actual number of the point for the y value. Can't do that on here. You can check your x and y intercepts here. Let me go back up to -4. It's right there. And then also there's an error at 1. That's because of the asymptote. And then for the y-axis, the horizontal asymptote, you can't really check it on the table. So what you're looking for is you can clearly see that the graph is starting to behave weirdly around 2 on the y-axis. It's starting to straighten out or flatten out, if you will, because it doesn't want to touch 2. So that's kind of your hint there. It just, it won't ever hit 2 on the 1. I was like, why does that look so low? Sorry. 1, you can tell it's starting to dance around it a bit. So y will never be 1 on the table. That's kind of hard to spot though. Alrighty. Domain and range. So looking at the domain, these are the x values. Pretty much the domain, you want to exclude the asymptotes. And actually, I did not do this correctly, ironically, on my answer key here, so I'm going to have to fix that. You want to exclude asymptotes and holes. Because basically, you're trying to leave out the numbers, the x values that you can't actually plug into the equation. So basically, those numbers that give you errors on the table, if you will. And there are 2 of them, -1 and 1. Sorry, -1 and 1. So when we write our domain, we need to exclude -1, I didn't mean to put the comma, and 1. So let's write that. We have negative infinity up to -1. We need to exclude -1, so we're going to put a parenthesis, meaning everything up until we hit -1. Then it stops at -1. We're excluding it. And then we have more to go. So this is when we use that union. Now we're going to pick back up at -1, but the parenthesis means it's being left out. Reminder, the reason we do that is because there's a bunch of numbers, decimals, close to -1 that can be used, but not -1 itself. So then from -1 to +1, all the numbers in between there are included, but we can't actually include -1 and 1. So we have to list those as a separate interval as well. So everything between -1 and 1 is good, but not these numbers themselves, which is why we have parentheses. Union, 1 more. Lastly, we're going to pick back up at 1. So now we're saying everything after 1 is included. So then we go 1 to positive infinity. So when we start and stop at the same number, when we're going from one interval to the start and stop, I should say. God, I keep saying it in the wrong order. Stop and then pick back up at that same number. We're basically saying everything, just not including this actual number. So all the negatives until -1, and then everything from between -1 and 1, but not including -1 or 1. And then we're picking back up again, everything after 1, but not including 1. Okay, range. Same thing, look for holes and asymptotes. So when we look at our y values, we have a hole here at -0.5. So -1.5. And then the horizontal asymptote of 1. I don't know why I keep wanting to write commas. So we're excluding -1.5, that's where the hole is, and we're excluding 1 because of the asymptote. All other y values outside of those numbers are included. So this is going to look very similar to the domain I wrote above. Negative infinity up to -1.5 is good. Union. The numbers between -1.5 and 1, the 2 excluded numbers. Union. And then all the numbers after, but not including 1. So again, we have to account for all of the intervals. So if these are the excluded numbers, we have to talk about everything before -1.5, everything between -1.5 and 1, and everything after 1. So 3 intervals here. All right, that is all for this video. I hope that this information helped. I hope it wasn't too overwhelming. If you have any additional questions, feel free to reach out to me either via email or in person, or if you have a different teacher and you're watching this, feel free to reach out to them as well. If you have any additional questions, let me know. Otherwise, I hope you have an awesome day. Bye.